people be able to share like if they're looking for a job or if there's opportunities, and they wanted to use gossip, so you only hear about your friends of friends. So I thought that was a pretty cool idea, and it seems like gossip is a pretty big core to that project. So.
Yeah, it's a bit like a testimonial system. So it's already friends you have, and you already have a recommendation of a network, and you have it created together.
Right. Yeah, that makes a lot of sense. That's a cool use case.
Mm-hmm.
Yeah, definitely. The people complain about the job market, but Urbit fixes this.
I mean, don't people already get jobs through rumors?
I think we have actually to this maybe. Okay. Yeah. Some of you might be familiar with rumors. And so the story of rumors is funny because I never expected it to take off in the way that it did. It was just supposed to be a super dumb like tech demo for the gossip library itself. Because rumors is just a very, very thin layer over the behavior that library provides.
Mm-hmm.
But yeah, it's like that library, it's called gossip. And you could say that, yeah, it facilitates gossip networking on Urbit. It's not true gossip networking, where traditionally you might think of that as like peers talking to, some subset of peers they know and just sharing data around endlessly that way. Libgossip on Urbit works a little bit differently in that it says, okay, I know, and one of the requirements for using it is that the ship that it's running on has pals installed, and then it uses pals, and depending on your configuration, it's like the people you have added or the people that have added you, or just the mutuals between those. Those are known peers that you can use to kind of bootstrap to set up a like gossip style data networking. So sorry, I got a little bit distracted. And so yeah, it's not true gossip networking in that sense, but it's still functioning like, oh yeah, you're on Urbit, you know some people that you're interested in, and then okay, let's just take that set and pull data from them. So the gossip library is supposed to make that super easy, and to like prove that point basically. I'm gonna share my screen, and what we're gonna do is, let's see, where are we at? What we're gonna do is walk through what it looks like to add the gossip library on top of an existing agent. So first of all, is this legible to everyone? Should I make this bigger, smaller? How's this looking?
Size is all right for me.
Okay, see some thumbs up. Perfect. Okay, so on the left here is a super dumb agent I wrote. It's called noun storage. And what it does is it stores some nouns in its state, right? Because, I'm big on nouns. I collect nouns, and so whenever I see a cool one, I wanna put that into my Urbit so I can keep it for who knows when I might need it, right? So very simple application. It doesn't do much. We say that we can poke it. That's like, only we may poke it. A little bit of security, and then we expect to be poked with nouns, so things with the noun mark. And then when that happens, we take our set of nouns that we have in the state, and we put the noun from the poke into that set. And that's it. We haven't, we've been a little bit lazy. We haven't implemented any subscriptions for getting the nouns out. We haven't implemented the scry interface for this. But really, what do we care about that? We get to store our nouns. Isn't that great? However, let's imagine that I'm actually not that good at collecting nouns. Like, I only come across interesting ones only a couple times a year, right? But I might have friends who also come across nouns, and so I wanna share my nouns with them and have them share their nouns with me. And so that is where the gossip library comes in. I have that open on the right here. I'm gonna go into chat here also and paste a quick link to the file that we're looking at. So that sweet repository, that's where all of my public source code lives, and so you'll find libgossip there. You can open that up yourself. I'm gonna just scroll through the documentation and look at some types here. So most of what we'll be doing will be visible on screen here. So okay, let's imagine I have never used this before. I open this file and it's like, oh, cool, data sharing with the pals, version number. This automates using app pals for peer and content discovery, letting the underlying agent focus on handling the data. Perfect. That's exactly what I want. Now, how do I use this? To use this library, we call its agent arm with an initial configuration. Okay, interesting. And a map of per mark noun to vase converters, and call the resulting gate with the agent store. Okay, so this is interesting. Like, the agent's door we already have. We wrote this whole agent, right? But then the library wants us to pass in configuration, which, okay, we might, connect two different people under different circumstances, and then a map of converters. This is, it's a little bit surprising, and so I'll talk briefly about why it needs that information. Normally, when you have two agents communicating over the network, they do that with marked data. So I send you, some noun, and I say, hey, this is a ship, or this is an atom, something like that. And then on your end, you have a ship mark or an atom mark, and then you can validate that the data I sent you has the shape that you expect based on the mark that I used to describe it. And so that's like basic data validation for network traffic. The library handles all of the network communication for you, but it still needs to know the shape of the data that you're sending along through the library itself. So this is maybe a bit of an implementation detail that's leaking out. It's not too difficult to provide this, though. We'll look at what that looks like. So the rest of this file, or the rest of the top of this file, is going to go on and describe in more detail, like, what the behavior of it is, and what the configuration looks like that we need to give it. We're not going to read all of this together. I'll just talk you through it as we hit all of these different points in the implementation. So, okay, we have some place to start here, at least. Like, we call the gate resulting from calling the agent arm with our agent, right? So that's our starting place. Well, Monfort, welcome. So, okay, so we know here we have an agent call, right? So we know we can work with that. And we know that we want to import the gossip library. So fazlus gossip. And then this says call its agent arm. Okay, so we're gonna call agent from gossip, but we don't call that with our agent directly, as it says we call it with an initial configuration and a map of converters, and then call the result of that with the agent. So we actually do two calls here. This is going to be configuration and converters. We'll split this up like so for legibility, and then fill in these blanks. So we might, if we're clever, it's like, oh, configuration, what does that look like? We can search for the config type in gossip and see that the configuration expects this shape. And there's a couple of little levers for us to play with. Going over these briefly in order, hops configures how far away gossip may travel. And so the default is set to 1, but the description here says that that is pals only. So again, like not true gossip if it's just, going only to the peers you're talking to directly. Naturally, 0 hops means that we don't expose any data at all. If we put a number here that's bigger than 1, that means that when we tell one of our pals something, they then see like, oh, this information should be traveling further. So they, let's see, the value is at 3. It's like, oh, it still needs to travel 3 hops. So they take off 1, needs to travel 2 hops because we just received it, and then pass it on to the next person, right? Okay, so hops. I'm gonna write this out in here. Let's say for now that I only want to hear about nouns for my friends directly. So that's going to be 1 hop, right? Next, here is who to subscribe to, and the who's type has 3 options. So we can subscribe to just anybody, any ship that is, discoverable through pals. So not just people that we added ourselves, but also people that added us, right? This is useful if you want to cast as wide a net as you possibly can. Alternatively, we can say that we want to listen only to targets, like people we've explicitly added. For, like, if you compare that with the anybody case, it's like, well, if like rumors is configured to listen to anybody, right? And so we all know how that turns out. You have a timeline, but it's kind of chaotic. If you would switch that to targets instead, then you could at least have some more curation, some more control over whose content actually shows up in your rumors timeline. Lastly, we could also restrict it even further and say, oh, we're only listening to mutuals, not just people we've added, but people who also consider us as a friend. This case is especially important if the next option is similarly restricted. And so let's take a look. The next option is tell who we allow subscriptions from. And so in our case, we have some nouns, and do we want to share these with just anyone who's willing to ask, or do we only want to share this with people we know and trust, right? And for different kinds of applications, the way you decide on that is gonna look differently. For our case, I think I want to say that I want to listen to nouns from what added as pals, and I want anybody to be able to see the nouns that I've collected myself. Like, they're just nouns, they're just numbers, man. And so we're fine with sharing that broadly. But there's a case here where you say like, oh, there's a case, a little bit of a mistake here you can make to say that, yes, we listen to anyone we're interested in, so targets, but then we only allow subscriptions from mutuals. And this gets you into a place where, like if everybody in the room here has this application, like some of you might have added me as a pal, but it might not have added you, right? And so according to the here part of the configuration, you'll be
That counts for me.
What was that?
Sorry. I'm pretty sure I'm in that boat.
Well, okay, so Jack is trying to subscribe to me for my nouns, right? Meanwhile, that subscription is going to come in to my ship, and it's going to look and see, hey, is this guy a mutual? No, he's not. Reject the subscription. But Jack is still configured to subscribe to me, and so we'll just periodically keep retrying to subscribe. And so that's something to keep an eye out for when you're deciding on how to set up this configuration. You generally shouldn't restrict the tell parameter more than it shouldn't be more restricted than the here one. So we're going to set this back to anybody to avoid that. And then the last configuration parameter here is pass, which says whether to, on a 50-50 chance, emit data through a proxy. Now, what does that mean? This is a little sort of anonymization feature that I added in specifically because it's a good fit for rumors, but it's also just a different way of doing data dissemination. I think in most cases you will set this to false and it'll be fine. But if you set this to true, the behavior of the library will change slightly, and there's a 50-50 chance that we'll use one of your pals to send data out to the network instead of having you yourself send it out. And so with that turned on, that gives people publishing data some plausible deniability about, well, was it you who published this, or did you publish it because someone told you, right? Jack?
Does that mean when you use rumors and this is turned on, there's a 50-50 chance your rumor actually gets sent to a different audience?
It's, yes, different audience in the sense that it will seem to originate from someone else. And so, yeah, if they're their two-hop connected network is different enough, then yes, it will hit different people, and it normally does.
I think.
And so, yeah, this does have implications for how far data might spread across the network based on your other configurations and based on the what the shape of the network of ships using your application looks like. For the nouns case, nothing about this is very interesting, so we're just going to set this to false. Again, you probably don't need this for most cases unless you're explicitly taking an, it's like anonymized, but on Urbit anyway, kind of implementation angle. I got to keep an eye on chat here. What's the upper bound to number of hops? The library doesn't enforce an upper bound to the number of hops. However, it does say that whenever it hears, whenever it receives from someone a piece of data that it has heard before, it just drops it on the floor and it doesn't forward it any further. So even if I set this to 99 hops, it's not going to bounce back and forth between people until it has made 99 hops. Because if it's gonna go to Jack and then to Sam, and Sam tells it to me, I'm like, I've already heard this, and so I won't forward it to anyone else, right? So in that sense, practically, the number of hops that might happen in practice is somewhat limited. In theory, yes, you could set that value to 9 billion and get like full PAL network coverage. There's some caveats there that we can get into later if you want. But yeah, there's not, like, the library doesn't enforce anything about what you put in here. Yeah, generally what you're looking at for hops is like either 1 for PAL data sharing or 2 or higher for, just like tell, a reasonably large portion of the network about this information. And then that portion scaling with the amount of hops. Okay, so that's the configuration. That's all it needs. But we still have converters here. And so we mentioned this previously, where it's like, yes, it takes marked. Like the library also deals with marked data, but because the library does the networking for us, we cannot rely on the general user space mechanisms for doing the mark conversions for us. So instead, what we need here is a map from mark to gates that take a noun and produce a vase. So they take some untyped data and produce data with a type attached to it. So we have this map here. Our case here is super simple because we're just dealing in nouns. So we can say put into that map for the noun mark a gate that takes a noun and then turns that into a vase directly, right? Now this is maybe too simple an example. In practice, you're probably going to be dealing with, I don't know, like a job listing mark, right? So maybe this looks like job listing instead, and then like we're still going to take a noun, but then we're going to have to convert into job listing that noun. So we still need to know what that conversion function would look like. Luckily, or depending on your point of view, unfortunately, but you've probably already written marks for your applications if you're doing network traffic anyway, right? And so it's possible for agents to implement mark conversion functions by saying fazbuck. And we want a conversion function from plain nouns to nouns with the job listing mark, right? Now I'm trying to remember, I think you do this, but I'm not entirely sure. Let me see if I have an example of this somewhere. Let's see. Nope. Rumors probably have it. Yes. Right. Yeah, so this is it. You just have to give it a name. So we're gonna call this grab job listing. And this says like, assign to this face the mark conversion function that goes from noun to job listing. Let's see, gossip here. And so the build system will just, see this import and fill this in for us. And then all we have to do here is say, instead of convert into job listing, grab job listing. Maybe even, I'm gonna double check this against existing source code again. Yeah, so you do say, just take the noun, and then we grab that thing. And the result of that goes into the phase, because that mark conversion function, the output of that is a typed noun. So a noun with the job listing type or whatever is relevant. And so that's our one conversion. Of course, like for our noun storage thing, we might write grab noun, convert from noun to noun, which would work in theory. That might be, the most consistent way to write this. But in practice, because noun is such a simple type, like these two lines are equivalent, right? If that doesn't entirely make sense, if that's, because like the mark system and stuff like that, there's details there that might be a little bit confusing. That's not the end of the world, as long as you can see how you would specify the conversion and then pass that into the library here. That's sufficient. The library makes use of this function, obviously, but you don't have to touch this beyond these like 2 lines in your source code.
So on line 5, the fazbook grab noun is using the grab and grow arms defined in the noun mark. And if you use
Yes.
2 different marks there, then you would get the grab and grow arms from those respective marks. And
Yes.
it builds what is essentially a 2, right? Or forget what's the
Yes,
proper
essentially.
called. And then you use that to apply to your n when you're specifying that function.
Yes. Okay, so that is it. No, that's not it. We're not nearly done here. But this is all the setup outside of our agent that we need, right? Because this agent is now going to go into the gossip library, and the gossip library then does its little enhancements. What we still need to account for, though, is the behavior of the gossip library, like how the library discovers the data that needs to be gossiped around, and what it does when it hears data from our pals. So you don't actually, like, you'll note we're still passing in an agent call. So nothing about the general structure of that changes. What the library does is it simulates certain events based on receiving data or wanting to send things. And so we're just going to start where the data would start when 2 of us install this application and these things try connecting to each other. So when someone tries subscribing to me for my nouns, remember we're dealing with noun storage here. When someone tries subscribing to me for one of my nouns, that's going to actually come into my agent as a subscription. And so we need to handle that. So onWatch takes a path and produces a equip card in this, so a list of cards, and then the new agent core. And the way this is going to get called when a gossip subscription gets established is that the path will be equivalent to sig gossip source, I think. And so, we have the documentation here, which says for new incoming subscriptions, the underlying agent's onWatch is called with that path, so it may give initial results. Okay, so we can now give initial results. Well, okay, what does that actually mean? What does that look like? Someone is subscribing for gossip to hear from us, but what do we tell them, right? What's an initial result? Well, we have an initial result. We already have a bunch of nouns in our state that we can tell them about. We could say we sent the entire set, which would be fine, but might be a lot. So maybe instead we want to take some subset of that, maybe the things we heard recently, or just something chosen randomly, and that's, a little noun to get them on the way. And we'll later, when we hear about more nouns, we'll tell them again. So we're going to say if we have no nouns, then, well, we can't tell them anything, right? There's no initial result. The subscription is legitimate, but we don't have anything to tell them. If we do have nouns, then end up nouns. It's going to be the first noun. And then, again, we're not changing any state here, so we're just producing this. And then here, we produce one card, or we give a fact for the subscription that was just established with the noun mark, and put the first noun in there. And that's it. We've taken, one pseudo-randomly chosen noun from our state, and whenever someone subscribes to us through Gossip for the first time, we just tell them that noun, right? To seed, their own noun database. Okay, so we give a fact. What happens next? On their end, they are going to receive this fact as a response to the initial subscription. The Gossip library is going to treat that just like receiving a piece of data, normally. So maybe later on, and perhaps we should do this first. Yeah, we'll do this first, because whenever I add a new mark, whenever I add a new noun to my noun storage, I want to gossip that out to the network also, right? So I add it to state here, but I also want to tell other people about it. Okay, so we've modified our state, so this is changed, but then we still need to give another fact. So we give a fact, but which paths do we give that fact on? We'll still do, that noun from the queue.phase. Let's name that new noun just for clarity. But we're not sure what exactly this needs to look like. Luckily, we don't need to know what exactly that needs to look like. We can call the invent function from the Gossip library and say, hey, we just invented something. Tell the world about it. It has a noun mark, and here's the vase. This is going to produce a single card that we can just emit in this function. Okay, so we've invented some data. And now we're publishing that out to the network. Okay, so then Jack has subscribed to me. I invent this new noun, and then his agent hears about it through a fact, right? It's as far as the library is concerned, it's treated the same way as if it was just the very first one. So what the library is going to do when it receives some piece of gossip data is first it's going to say, have I received this before? If it has, it just drops it on the floor. It doesn't do anything, right? You don't, and again, this is to protect against the data bouncing around case. Like, you don't want to act on the same datum multiple times. So if it detects that case, it does nothing. However, if the datum is actually new, then it's going to do two things. It's going to call our agent, and it's going to, if necessary, continue, gossiping it out to the network. Like if there's hops remaining, it will, tell it on to whoever is subscribed to us. So the way it's going to call into our agent is through the on agent arm, because it's it's like sort of like, oh, we just got a fact on a subscription, which is true. It's a subscription the library established for us, but it's true nonetheless. And so on agent gets called with a wire and a sign agent call as normal. And then for the case where we hear data from the network, the library is going to set a wire for us, a wire that we didn't create ourselves, but it's going to use that wire to signify to us that, hey, this came from the library, please handle this as appropriate. So again, it's going to start with sig gossip, and then it's like, oh, it's a piece of gossip, right? Like it's a new datum that we just received. And so in this case, the sign is going to be a fact, right? We received a datum over the network. The library guarantees that if this is the wire in the on agent call, then the sign will always be a fact. In fact, it's also going to guarantee that the P dot sign, no, I'm trying to remember the faces on this type. Yeah, so it's just a cage. So it's P dot cage dot sign. Remember that a cage is a pair of mark and vase. And so it's going to guarantee that the mark is whatever we originally, like whatever the other agent originally sent it out with. And so in our case, we know that in both the creation case and the subscription case, like we're just dealing with nouns here, right? So the mark for this is going to be noun. We might, if you have a more complicated application, you might be sending both nouns and a custom mark, or like multiple different kinds of things, right? In this, dumb example app, we're only sending out nouns. So here we have a new noun, and we say that we unpack the vase from the cage into a new noun. If we want, we might say that, oh, we heard this from this person, right? And so we can incorporate the value from the source.bool into how we handle this noun, or how like how we store it in state. But you have to remember that this is only the person we heard the data from. If you have multiple hops configured, or you have the proxy flag turned on, then that might not be the person that the data originated from, right? It's just the person that eventually relayed the information to us. If you actually want provenance of that, you can do message signing and include that in the datum that you're gossiping around. For this example case, we'll not worry about that. In fact, we might just omit this printf entirely. But there's multiple things at play there worth keeping in mind. Okay, so we have a new noun. So why don't we put in nouns, a new noun, we put it in state, and then that's it. And you're like, wait, don't we need to do anything else? It's like, no, we just put it in state. Because if we need to forward this on, which for our specific application we don't, but if we still need to forward the data on, then the library will take care of that for us. And so this is actually it. These are all the changes you need to make use of this gossip library. You need to signal that you're inventing new data that you want to share out. You need to support the subscription path and maybe give some initial data, which is entirely optional. You could also not give any initial data and just be like, well, you're too late. Like, you'll only hear about the latest ones and not any of the historic stuff, right? That's legitimate. And you need to handle being called with new datums that you received over the network. And that really is it. Of course, this is, noun storage. It's a very dumb, very simple agent, but the same pattern for adding support for it holds regardless of what you're trying to build. So I have actually written, and you saw me pull this up earlier, I have written somewhat extensive documentation for this library that covers all of this. I'll post a link to that in chat right now. That goes over the behavior and the things to keep in mind in a little bit more detail. But yeah, that covers most of what we covered here just now. Also has a similarly dumb example. And yeah, that is it. Do you guys have any questions for me about this? Quiet audience.
Yeah, thank you so much, Mark, for volunteering to do this. We know you're certainly quite busy with many other development tasks, many other things, but yeah, I know people here really appreciate the hour of your time, and this is going to be recorded, so there will be many others who will certainly get to enjoy this.
Wait! I'm on the record?
Yes. Everything you said here will be used against you.
That is certainly news to me, but well.
Yeah, dude, I've got everything.
All right. Yeah. So if anyone here has questions about what we just covered or specific about how this might relate to your application, I would be happy to delve into that more. And if nobody does, then we can.
Glenn, if you have any particular questions on how to use this with your job listings, now's your chance.
Actually, I have an interesting question about provenance because you mentioned data signing.